In these next couple of examples, now we will be graphing systems of inequalities, but they're not all linear now. So for example, if you look at number 5, that very first inequality says x squared plus y squared is less than 9. When we have x squared and y squared, remember that that's a circle, right? So this represents a circle. I can tell that by the x squared and the y squared. So as a reminder, x squared plus y squared, since there are no shifts horizontally or vertically, this circle has a center at 0, 0. And then remember that on the right side, usually of the equation, but in this case, the right side of the inequality, we have r squared. So if r squared equals 9, that means that our radius equals the square root of 9, which is 3. So we can go ahead and graph this circle. It's centered at 0, 0 with a radius of 3. So 3 to the right, up 3, 3 to the left, and down 3. When I graph this, I'm going to use a dotted rather than solid pattern. Because I have that less than instead of less than or equal to. Then it comes to the shading. So we don't think above or below for our circle shading. Instead, shading for circles, I wrote our rules over here. If you have less than or equal to, you would shade inside the circle. So the shading should be inside the radius, less than the radius. And greater than or equal to means you shade outside the circle, so you want to be greater than that radius. So in our case, because we have less than 9, we want to shade inside our circle. So I'll go ahead and just lightly shade inside. Let me see, I'll just use the purple marker. So I'm going to shade lightly inside here. Oops. Well, whatever. I'll just keep using this. So lightly shading inside, and then I'll just erase that later. All right, so we've shaded inside the circle. And then for our second inequality, we've got x plus y greater than 3. I'm going to solve that for y. So y greater than, not greater than or equal to, just greater than negative x plus 3. So I go up to my y-intercept 0, 3. Negative 1 is my slope, so negative 1 over 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down to the right 1, on and on and on. Because it's greater than inequality, I'm going to use, again, a dotted line when I draw this. Oh, sorry, let me fix my drawing because it's going to look really sad if I don't. I didn't draw the best circle here, guys. So I've got my dotted blue line, and then my circle goes out here. Okay, so remember that I already shaded inside my circle, and then I also want to shade above. I want to shade, because it's greater than inequality, I want to shade above my dotted blue line. So that means that I only want to shade inside the circle above the dotted blue line. So that's going to be this little area right here, this little sliver of my circle, right? So I'm going to erase this shading inside the circle. That's not where the overlap occurs. So it's just this sliver that's greater than, above that dotted blue line, but still inside the radius of the circle. So that would be my final answer. All right, for number 6, again, my first inequality represents a circle. Here we've got a circle that's centered at, because it says x plus 1 squared, centered at negative 1 for x. And then y minus 1 squared means positive 1 for my y coordinate. And then again, r squared is 9, so that means that r equals the square root of 9, which is 3. So I have a circle centered at negative 1, 1, radius of 3, 1, 2, 3, up 1, 2, 3, left 1, 2, 3, down 1, 2, 3. And again, I'm going to use a dotted circle graphing this. So maybe this will look a little more circular than my last circle. We'll see. right? It's still a little wonky, but bear with me. And remember that because it's less than, that means I'm going to shade inside the circle. So far I'm shading in here, and I will be erasing portions of that shortly. All right, and next I have y greater than or equal to x squared plus 1. Because of this x squared, this is going to be the graph of a parabola, right? Remember our quadratic equations, y equals x squared plus 1, for example. So because this is a y equals, I could go ahead and graph this in my graphing calculator just to remind myself of what this looks like. Y equals x squared plus 1. It's a parabola with a vertex of 0, 1. So if I go up to 0, 1, that's my vertex, and I could use trace to plot other points. Goes through 1, 2, and then by symmetry, I know it'll go through negative 1, 2. If I plug in 2, I'll have 2, 5. And then by symmetry, I know that I'll have negative 2, 5, and so on. Because I have greater than or equal to, I'm going to graph this as a solid parabola. All right, so now let's talk about the shading for a parabola. So we have y greater than or equal to. We can still use our above or below rule. So greater than or equal to means shade above my parabola, right? So if I'm shading above my parabola, that's going to look like this. I'm going to shade up above toward that up arrow, right? And you can see where the overlap occurs is still inside the circle, but up above my parabola. So for my final answer, I'm going to get rid of this shading that's outside the circle. Hopefully I don't erase my circle. Got to be careful here. Okay, oops, chopped off a slice of my parabola. I'll fix that. All right, and I want to erase the shading inside my circle that exists below my parabola. Okay, so my final answer is going to be the solid parabola, the dotted circle, and just this shaded region above the parabola, but still inside that circle. All right, so for my parabolas, just to do a quick sketch, if I have, y greater than, or I'll do greater than or equal to, just x squared, y greater than or equal to x squared. So here's my parabola going through 0, 1. If I have y greater than or equal to x squared, I would shade up above like this. Y less than or equal to x squared, I would shade below. So all this stuff below would be shaded. And if I have a downward facing parabola, y greater than or equal to negative x squared, so there's my downward facing parabola, I would shade above. I would shade above my parabola like this. And if I have y less than or equal to negative x squared, I would shade down below my downward facing parabola. Like that. Okay, just to give you guys some parabola examples.